number 3, chapter 6, pages 196 and 197. Here's one of our first problems that we come into contact with. We have a 2,500 kilogram car is slowed down uniformly from an initial velocity of 20 meters per second to the north by a 6,250 Newton braking force that's acting opposite the car's motion. What is the car's velocity after 2.5 seconds? This is one of our bigger problems. We want to go through and use our guess method so that we're able to break down the problem. So let's go back and we'll take this, of course, step by step. We're going to start with our given information. And remember, from the guess method, everything that has a unit or any word that can include rest or coming to a stop is going to be important for us. We're going to start with step number 1, which is letter G. So let's read. We have a 2,500 kilogram car. 2,500 kilograms will be your mass. You know that it's mass because it is measured in kilograms. It's slowed down uniformly. Have we seen the word uniform before? The answer is yes. This could possibly be a kinematic equation. So that's where that word is letting you know the object is moving, but it's also moving at a constant pace. We have an initial velocity of 20 meters per second. V is for velocity. We're going to use the subscript of I for initial, and this is at 20 meters per second. To the north. Now, what I normally do is I draw me a little arrow and I put the directional term. So that way, if I get a negative, I know that the object stopped going north and went the opposite, which is south. By a 6,250 Newton force. What do we know that is measured in newtons? You got it. It's force. All right, so our braking force is acting opposite the car's motion. We're trying to slow this car down. What is the car's velocity after 2.5 seconds? The word after tells me that we are looking for the final velocity. Now, whenever I have mass and velocity, I'm thinking about momentum, right? P equals M times V. But they also gave me force, which kind of brings you back to your equation that you just learned for impulse. So we're going to use the following equation. You have learned that force times time equals momentum. You also know, if you come down to your substitution step, that momentum is equal to what? Mass times velocity. So we will replace the P with M times V. Now, here's the question. Can I take the velocity to the next level? We've seen before where we've used a triangle for velocity. And the triangle will normally tell us that you have V final minus V initial, right? So if I'm going back and taking a look at my text, I know that the same thing is going to apply. We're going to substitute and turn this equation into V final minus V initial. And your mass is still there. All right? So we started with our impulse. They gave us force. We have time. And they have momentum. We then had to pause and remember that momentum, P, is equal to mass times velocity. Now we know that that velocity can have the delta sign or the triangle, which is where my V final and my V initial have come from. What question do we need to ask ourselves before we move out of our substitution step? We're going to go back and make sure that all my units are SI units. They're international. They're okay. And we're good there. Now, let's go over and let's start to solve. I'm going to plug in my force that was 6,250 newtons. Time. Anything about time? I don't think so. Take it back. We missed a little of our given, right? We had 2.5 seconds. So let's just squeeze that in. So my time is 2.5 seconds. The mass, 2,500 kilograms. my V final, which is what I'm looking for. Whatever you're looking for, make sure you put that variable into your equation. So we're just going to put V final minus my mass again, which is 2,500. And they gave us the initial, which was 20. Force was 6,250 newtons. My time was 2.5 seconds, given information. Our mass was 2,500. Your final velocity is what we're looking for. It's my unknown. I have my mass again, and of course, the initial velocity. Grab your calculators. It's time for us to get to work. We're first going to multiply 6,250 times 2.5. And you should come out with a number of 15,625. Now, what you're going to notice, or what I don't want you to forget, is the force was acting opposite motion. If I'm already moving and something is coming opposite, will my force remain positive or negative? It's going to be negative, which tells me it's going in the opposite direction. All right? We will multiply 2,500 times your VF. And then we have 2,500 times 20, which should give us 50,000. Hopefully everybody is still with me and still feeling pretty good. Now, we've got to move some things around because eventually this final velocity has to be by itself. So if I'm looking to make things simpler right here, I want to move 50,000 from this side of my equation to the opposite side of my equal sign, right? So what's the opposite of subtracting? You got it. We're going to add on both sides. Once we add, if you think about it, what's going to happen here? These two cancel out. We're going to keep our 2,500 times VF on this side. And we're going to say 50,000 minus 15,625, which should give us 34,375. From here, it's all about the math. Take your time. If you think about it, V final wants to be alone. Between these two, what are we doing? Are we adding? Are we subtracting? We're multiplying. Now, in order to move it, we have to do the opposite. So on this side, I'm going to divide by 2,500. How did you pick 2,500? Because VF wants to be alone. Whatever I do on one side, I also want to go back and do on my opposite side. It's always that question. What's going to happen here? 2,500 on top and bottom. These two are going to cancel out. So this final step should give me my final velocity. When I go through, we're going to figure out that it is 13.75 meters per second to the north. And that will be your final answer after dividing. This is the final speed at which our object is traveling. All right? So if you take a look, they provided us with mass, your initial velocity, force, and also time. And as you saw me do earlier, it's very easy to skip a part of your given. So as you're working through your problem, because we were using the guess method, the first thing we caught was that we hadn't written down time. Your unknown was final velocity. We started with our initial equation for impulse because it included force, so it helped us narrow it down pretty quickly. We replaced our P with mass and velocity because this is the equation for momentum. We will remember in the back of our minds that if we're looking for final velocity and we're given initial velocity, those two will have to be subtracted. Pay attention to your order. Plug in your numbers, make the appropriate substitutions on both sides, and you end up with your final answer. All right? Now, here's another one. that I want you guys to pay attention to. We'll go ahead and identify parts of your given, and then I'll walk through, and if you happen to get stuck, you'll be able to figure out exactly where. Problem number 2, a pitcher claims he can throw a 0.145 kilogram baseball with as much momentum as a speeding bullet. Assume that a 3-gram bullet moves at a speed of 1.5 times 10 to the third meters per second. What is the bullet's momentum? You take a second. I want you to work this problem out, and I'll go ahead and work this one out as well.